Hello everyone, this is Seyed Moosavi and I'm going to talk about the theory of constraint. The theory of constraints focuses on eliminating the constraints in the production line to maximize production flow. This is very effective and quick method for increasing revenue in modern industry. In this presentation, we are going to talk about the reason that we chose this subject, the definition of throughput, and we will take a deep look at the theory of constraints. As you know, in today's world, the quality and performance of each production line is assessed by its throughput. The throughput in a manufacturing system is the amount of a specific service or product that a company can deliver to a client in a specified frame time. There are other terms interchangeably used to describe the throughput of a system, such as the production rate, the speed at which something is produced, and the flow rate.
Well, given that the goal of the production rate of line is maximizing the revenue of the company, and it is crucial, me and Benjamin as a group decided to study the theory of constraints applications in production lines and try to present a new point of view in maximizing the performance of line. Here, we get to know different types of bottlenecks in a system as well as how to combine lean manufacturing and theory of constraints methods and using some of lean manufacturing tools such as Kaizen, Jidoka, Gimba, TDM, SDEM, and so on to identify and eliminate the constraints, align and maximizing the total output. Now we are going to understand the exact meaning of throughput. Production capacity of a company is closely related to production rate, and a business manager can make a number of assumptions about the throughput of the system. On paper, a company can reach the maximum capacity, assuming that the line will operate continually and without any interruptions, but in the real world scenario, it is not possible. Over the years, in a production line, machines will fail and need to be repaired. There will be changes in the personnel of the factory and learning curve altered during time. There are always maintenance and overhauls needed after a certain amount of operations time, and there will always be some supply chain shortages in the line that will lead to wait time. There are also certain products that begin in production line using the same process, and the joint costs are allocated between each product. But when production line reaches a certain split off point, then the products are produced using separate processes. This simulation makes it a lot more difficult to maintain a high level of throughput. Therefore, the theoretical capacity of line will have no use for a company, and the managers must always take these constraints into considerations.
The key concept of this theory is that every production line has a single bottleneck, and the total production rate is affected by that constraint in the line. Consequently, when that constraint is eliminated from the line, the total line throughput could be improved. Thus, spending time on optimizing the non-constrained parts of the system is not very beneficial in the process, and the only improvements on the weak links of the system will improve the overall efficiency. TOC also will provide precise and sustained focus on improving the current constraint until it no longer exists or be at the minimum state. And at that point, the focus will shift to the next bottleneck in the line. This process continues until all the constraints in the system are fully eliminated or minimized. Focusing only on what constraint at a time gives the system a very strong attention towards a single goal until it is eliminated.
But before, we need to find out the main characteristics and also the benefits of TOC. One of the most appealing advantages of TOC is that it always prioritizes the improvement activities, and in contexts that need urgent improvement of the line, TOC offers a very rapid method for improvement.
In continue, if this method implements successfully and correctly, the following benefits will be achieved, including increasing profit, which is the primary goal of most of the companies, fast improvement, which is the result of full attention and focus on the most important bottlenecks of a system, improved production rate by eliminating the bottleneck from a system, the throughput always increases, and the reduction in lead times, eliminating the bottleneck results in faster production flow, and eliminating inventory. And now I'm going to take a depth look at the theory of constraint. It is a methodology for identifying the most important limiting factor, I mean constraints, that stands in the way of achieving a goal and then systematically improving that constraints until it is no longer the limiting factor. In manufacturing, the constraint is often referred to as a bottleneck. This theory takes a scientific approach towards improvement, and the basic assumption in this theory is that every complex system, including manufacturing processes, consists of multiple linked processes, and one of these activities will always act as a weak link in the production line and affects the whole system throughput. Now TOC will try to recognize that weak link in the system, and by eliminating that link will maximize the total output of the system, which ultimately results in more income both in short and long term for companies.
There are five steps focusing on theory of constraints. The first step is the identifying the weakest link, I mean the most important constraint. The second step is exploit the constraint. It means that you can think about the most and most effective and quickest way to improve the constraint. On the third step, we subordinate everything else to the constraint. It means that we need to review all over the activities of the line to ensure that everything is aligned with the constraint. And at the fourth step, we elevate the constraint. It means that if after all the three steps before, the constraint in the line still exists, then we need to consider further actions to move the constraint. And for the final step, we need to repeat these steps again.
The sophisticated problem-solving method used in the theory of constraint is called the thinking processes. This method is optimized for complex systems with many interdependencies. They are designed as scientific cause and effect tools which are applied to first identify the root cause of undesired effects, UDES, and then removing them without creating the new ones. The thinking processes are used to answer the following questions, including what need to be changed in the line, what should it be changed to, what actions will lead to this change, and the tools included current reality tree, evaporating cloud tree, future reality tree, and strategy and tactics tree. The third method is throughput accounting. In traditional accounting in companies, the inventory has been considered an asset, meaning that in theory they have the potential to turn into cash. This assumption usually results in undesirable behavior at companies, and some of them will try to manufacture and store up products that are not really needed. The accumulation of products in the inventory generates a paper profit which may never turn to cash because of different reasons like obsolescence. On the contrary, the theory of constraints considers the inventory a liability. TOC believes that inventory looks up cash that could be used somewhere else more productively. The traditional accounting also has a strong emphasis on cutting expenses, but on the other hand, TOC considers cutting expenses to be of much less importance than increasing the throughput. The core throughput accounting consists of three main elements, including the throughput, investment, and operating expense. The four key measures in throughput accounting are net profit, return on investment, productivity, and investment term.
Okay, anything that prevents a company from reaching its goal is considered as a constraint. In industry, we recognize the constraint as bottleneck. The bottlenecks in the line are not always the equipment types and they can have different natures. The most common approaches to categorize the constraint is as below. As you can see, it is physical, policy, paradigm, and market. There are also different opinions on whether a system can have more than one constraint. The conventional wisdom is that most systems have one constraint and occasionally a system may have two or three constraints. In manufacturing plants where a mix of products is produced, it is possible for each product to take unique manufacturing path and the constraint may move depending on the path taken. This environment can be modeled as multiple systems, one for each unique manufacturing path. Well, now there is an example of applying theory of constraint in reality. It includes 5 steps that I mentioned before, including identifying the bottleneck, exploit the constraint, subordinate and synchronize to the constraint, elevate the performance of the constraint, and repeat the process. The first step is identifying the bottleneck. In this step, the manufacturing process is reviewed to identify the constraint. A simple but often effective technique is to literally walk through the manufacturing process looking for indications of the constraint. The deliverable for this step is the identification of the single piece of equipment that is constraining process throughput. The second step is exploit the constraint. This step focuses on quick wins and rapid relief, leaving more complex and substantive changes for later. The deliverable for this step is improved utilization of the constraint, which in turn will result in improved throughput for the process. If the actions taken in this step break the constraint, we jump ahead to step 5, otherwise continue the step 3. In this step, the focus is on non-constraint equipment. The primary objective is to support the needs of the constraint, for example, subordinate to the constraint. Efficiency of non-constraint equipment is a secondary concern. If constraint operation is not adversely impacted, all non-constraint equipment has some degree of excess capacity. This excess capacity is a virtue as it enables a smoother operation of the constraint. The manufacturing process is purposely unbalanced. Some useful techniques for this step include DBR, priority, sprint, and steady operations. In the step 4, more substantive changes are implemented to break the constraint. These changes may necessitate a significant investment of time or money, for example, adding equipment or maybe hiring experienced staff. Uh, the key is to ensure that all such investments are evaluated for effectiveness, and the deliverable for this step is a significant enough performance improvement to break the constraint. In the final step, the objective is to ensure that the 5 focusing steps are not implemented as a one-off improvement project. Instead, they should be implemented as a continuous improvement process. I would like to thank you for